Let's talk about complex fractions. Now, they might sound a little complex, but they're really not that bad. A complex fraction is basically, in a nutshell, one big fraction with another fraction in the numerator or the denominator, or maybe even both. So you might see something like 1/2 over 2/3. So as a whole, I have a big fraction with a numerator and a denominator, and in the numerator is 1/2, in the denominator is 2/3. Keep in mind that fractions are just division. So this is really 1/2 divided by 2/3. So I could just rewrite it as a 1/2 divided by 2/3, and then it looks a little bit more friendly. From here, if I'm dividing two fractions, all I need to do is multiply by the reciprocal. I keep my 1/2 and then I multiply by the reciprocal of my divisor. And then I just multiply straight across. Multiplying the numerators, I get 3, and the denominators, I get 4. Now, without having to rewrite this using that little division symbol, I could just take my numerator 1/2 and multiply it by the reciprocal of that denominator, which would be 3/2. So we end up exactly where we were down here, but we didn't rewrite it first. We just jumped straight to numerator divided by the denominator, which means multiply by the reciprocal. I then multiply straight across. 1 times 3 is 3, 2 times 2 is 4, which gives me that 3/4 that we had before. Now, this is just one of two approaches. We could go about it a different way, so let me go ahead and clean this up and show you what that would look like. When we're working with fractions, remember that we're allowed to multiply anything we want as long as we do the same thing to both the numerator and the denominator of the fraction. So what I'm going to do is look at my big fraction, and I'm going to multiply the entire numerator and the entire denominator by the same factor. What I'm going to multiply by is the number that will cause both of these fractions to reduce. So in the numerator, I see a denominator of 2, and in the denominator, I have a denominator of 3, which means I need to multiply by something that has both the factors 2 and 3. So that would be 6. So I multiply my entire numerator by 6, my entire denominator by 6. And when I multiply, it might be easier for you if you put 6 over 1. You don't have to. I can then multiply straight across or reduce first, whichever you're more comfortable with. If you're not comfortable reducing first, we just multiply straight across. 1 times 6 is 6. In the denominator, 2 times 1 is 2. Over, I multiply straight across again. 2 times 6 is 12, over 3 times 1 is 3. Now, if I look at the top of that big fraction, this 6 over 2, that's just 6 divided by 2, which is 3. And in the denominator, I have 12 divided by 3, which is 4. So I still got to that 3/4. I just went about it a different way. Maybe you want to reduce before you multiply. So here's what that would look like. In my numerator, I'm multiplying 1/2 and 6. I can reduce both the numerator and the denominator by 2. I can reduce this 2 down to 1, and my 6 would divide down to 3. Now when I multiply those numerators. 1 times 3 is 3, over my denominator of 1 times 1, which is just 1. Now 3 over 1, I don't need to write that denominator of over 1, so this is just 3. In the denominator, I can also reduce. I have a 3 and a 6 that will reduce down to 1 and 2, and then I just multiply straight across. I have 2 times 2, which is 4, over 1 times 1, which is 1, and again, I don't need to write that over 1 because it's implied if I just write 4. So we still got to our same answer of 3/4. So lots of different ways you can go about this. Let's go ahead and try a couple out. If at any point you want to pause the video and try these on your own, go ahead. I'm going to start working through number 1. So we've got a few different options. My first is to just look at this big fraction. And because I have a single term on top and a single term on the bottom, I can go ahead and take my numerator and multiply by the reciprocal of the denominator. So I kept my numerator the same, I flipped over my denominator, and then I changed to multiplication. From here, I reduce 5 divides down to 1 and 10 divides down to 2. And I get, when I multiply, 2 times 2 is 4 over 1 times 3 is 3. Now we could do this a second way if you wanted. We talked about multiplying the numerator and the denominator by the LCD. I need to multiply the entire numerator and the entire denominator of the big fraction by the same term. I know that I need a factor of 5 in the numerator to reduce that 5. In the denominator, I need a 10, which is 5 times 2. So 10 will be my LCD. I'm going to multiply by 10 in the numerator and denominator. And if you prefer to write it as 10 over 1, you're more than welcome to do that. Instead of multiplying first, I'm going to jump straight to reducing. In my numerator, I can reduce my 10 and my 5 down to 2 and 1. Then I multiply straight across. 2 times 2 is 4 over 1 times 1 is 1. And again, I don't need to write that 1 because it's implied with just 4. In the denominator, I'm going to reduce my 10s down to 1 and 1. I multiply straight across. 3 times 1 is 3. My denominator, 1 times 1 is 1. Again, that's just 3. So I got the same thing, but maybe a little less work doing it this way. But either way, whichever method you're more comfortable with, you can use. Let's go ahead and take a look at number 2. Personally, I prefer that second method of just multiplying by the LCD, so that's what I'm going to do here. I take my entire numerator and my entire denominator, and I'm going to multiply by my LCD. Looking at my two denominators, I have 15 and 5, so the LCD would be 15. I multiply the top by 15 and the denominator by 15, or 15 over 1. Now in the numerator, the 15s reduce completely down to 1 and 1. So when I multiply, x squared times 1 is just x squared, and my denominator reduced completely, so I don't need to write that 1. In the denominator of my big fraction, I can reduce my fractions by 5 to get 1 and 3, and then I multiply. 2x times 3 is 6x, and my denominator is again just 1, so I'm not going to write that. Now from here, I can actually simplify a little bit further because I see that the numerator and the denominator have a common factor of x. That numerator, if you're not comfortable with this, can be written as x times x over 6 times x. So since I have that common factor of x in the top and the bottom, I can go ahead and reduce that down, and I would be left with x over 6. You could write it out like that, or you could just use properties of exponents to subtract. I look at my larger power, which is in the numerator, and then I subtract the power of the x on the bottom. There's an invisible 1 here, so I would subtract that 1x that's on the bottom. So now this x in the denominator has been reduced with the numerator, or just moved up to the top, and I have x to the power of 1, which is just x, over 6. So that's generally how we would reduce those powers of x, but if you're uncomfortable, you can always write it out like I did down here. All right, number 3. I'll take my entire numerator and my entire denominator and multiply by the LCD. The LCD would be, in this case, my largest power of c, because both of those fractions have denominators of c, so I just need to make sure I have enough to reduce all the c's. I have 1 c here in the denominator of my top fraction and 3 in the denominator of my bottom fraction. So I need to multiply by c to the power of 3 to make sure that I reduce c's for both of those fractions. I can reduce my c down entirely to 1, and here I have 3, but I'm canceling out one of them, which would leave me with c squared. So in my numerator then, I have a squared times b squared times c squared, and my denominator is just 1, so I'm not going to write that. In the denominator of my big fraction, the c to the thirds are going to reduce completely. So all I have left is that a b to the third times 1, which I don't need to write, and all over 1, which I also don't need to write. From here, I can reduce because I see common factors of a and b in the numerator and denominator. My a's, I have 2 in the numerator and 1 in the denominator. So I'll cancel out one of the a's from the bottom and reduce 1 from the top, leaving me with just a to the first in the numerator, or just a. My b's now, I see 2 in the numerator and 3 in the denominator. So I'm going to reduce both of the 2b's from the numerator, and I will reduce my exponent in the denominator by 2. So I'm taking those 3b's and I'm essentially crossing out 2 of them. So I'm left with just b in the denominator. My c term doesn't have anything to reduce with, so that's just c squared. And this would be your simplified form. And for now, that's it. There's a lot more to learn when it comes to complex fractions, but this at least gets you started with how to simplify when you've got a fraction divided by another fraction. We can either multiply by the LCD, or if you like it better, you can flip and multiply by the reciprocal. Either way works. Thanks for watching, and I'll see you next time. Bye.